.NET 5 is the future. It will combine the old .NET framework with .NET Core, and that's why it's about time to update this course with the latest version of .NET. You will learn the crucial stuff about web development with Web API and Entity Framework in .NET 5 in no time, so that you're able to join new projects and companies who are craving for .NET developers like you very soon. With the example application we're going to build, you will be able to create, read, update, and delete contacts. We will use people you might even know, like Peter Parker or Tony Stark. The tools we're going to use are the .NET SDK, of course, together with Visual Studio to write our code, Postman to make our REST calls, and SQL Server Express for our database. Everything is available for free, so you already have everything you need to start developing with .NET 5. A few minutes into the course, you will already make your first Web API call. After that, you create your own model and controller to make use of the model view controller pattern and implement all CRUD operations, meaning create, read, update, and delete, with the corresponding HTTP methods get, post, put, and delete. Then you will make your data persistent with the help of the Object Relational Mapper Entity Framework and Code First Migration. With all that knowledge, you are ready to conquer any .NET 5 backend application. My name is Patrick and I will be your instructor in this course. I'm a web developer for over a decade now. I have worked for big corporations and small teams, as an employee and a contractor, and I just love to see the way Microsoft is going with .NET and how important it gets day by day. So I hope you're ready for your new skills and your new projects. I'm looking forward to seeing you in the course. Welcome to the .NET 5 Web API and Entity Framework crash course. In a short period of time, you will learn to get the latest version of .NET 5, build a Web API with .NET 5 and Visual Studio, and also use Entity Framework with Code First Migration to save your data persistently in a SQL Server database. We will start by creating a new web application and already make our first Web API call within the very first minutes. Additionally, we will create a new Git repository for your local source control. You could also push that repository to GitHub, for instance. Then we dive deep into the Web API. You learn about the model view controller pattern and create your first model and controller by yourself. We will talk about HTTP request methods, proper return types and status codes, and implement all CRUD operations, meaning create, read, update, and delete. In the subsequent section, we will do the same with Entity Framework, only this time your changes will be saved persistently in the SQL Server database. Alright, let's start by downloading and installing all the necessary tools. Before we can start developing our web application, we have to install the .NET 5 SDK, Visual Studio, and Postman. The easiest way to get all this is simply by Googling for it. Let's start with the .NET 5 SDK. Depending on when you are watching this course, there might be different versions of the SDK available. As you can see in my case, I am working with a preview version of the SDK. In your case, it might be already the released version. Anyways, choose the proper version for your operating system and install it. I'm working with a 64-bit Windows system, so I download and install the 64-bit version. To get the Community Edition of Visual Studio 2019, again, just Google for it. And again, depending on when you're watching this video, you might have to pay attention to the actual version you're installing. If .NET 5 is officially released, everything should work with the current version of Visual Studio 2019. But in my case, I have to get the preview version of Visual Studio. As you can see in the Visual Studio installer, there's a preview and a non-preview version. The .NET 5 SDK currently only works with the preview version. So to make this clear, If you're working with a preview version of the SDK, you better get the preview of Visual Studio. If you're in the future where .NET 5 is officially released, just get the current released version of Visual Studio. One more thing, when you're installing Visual Studio, make sure to check ASP.NET and Web Development to install all the necessary components. Last but not least would be Postman. We will use Postman to test our Web API calls. That's it. Sounds simple, and it is, but that's still very helpful, because we don't have to build a front end ourselves. So just search for Postman and install it. That's it. When everything works, we can start to build our first web application with .NET 5. To create a new web application, we could continue without any code to open the IDE without a project, or we create a new project right here. The wizard can be a bit misleading, so that creating a .NET 5 project is a bit tricky at first, but let's do this together. We create a new project and then we are already able to choose one of the many templates. I already filtered by C# templates because you could also build this thing in Visual Basic, but that's not what we want to do. Now we can search for web application, for instance. As you can see, there's a .NET Core template and a .NET Framework template. To save you time, choose the .NET Core one. Since .NET 5 combines the .NET Core framework with the older .NET framework, Microsoft seems to keep the core term internally. So, ASP.NET Core Web Application with C# it is. Then we give this project a name and we already get the option to click Create. A bit strange because we haven't chosen the SDK version yet, but this comes in the next step. And here's another tricky part. We have to choose .NET Core in the first dropdown, and then we are able to finally select the .NET 5 SDK. In this case, still called .NET Core. Again, this might be different when you're working with the final version of .NET 5 and not the preview. Regarding all the other options, we choose the API template. With that template, we get the necessary components and a little structure for our backend web application, and we also get a small example we're going to talk about in a minute. We don't need authentication, and to make our lives a bit easier in the beginning, we uncheck the HTTPS option. One last thing I'd like to mention is that you see the current version of the SDK at the bottom right. Okay, let's create this project. When the project is created, let's have a look at the Solution Explorer and all the files that have been generated for us. If you're not familiar with Visual Studio, please have a look around first and try to make yourself at home. Visual Studio is big, but it's sufficient to just focus on the parts I am explaining in this course. You will learn all the necessary features lecture by lecture. For now, you just need to know that you find all project files in the Solution Explorer and the actual code is visible at the center of the IDE. Alright, let's see. Of course, we've got some dependencies, which are .NET Core libraries in essence. The first interesting file is the launch settings JSON file in the properties folder. It will describe some settings for launching the application. We don't have to dive deep into the file, but as you can see, there is an IIS settings section and another section at the bottom. In the toolbar, you can see that we can start the application with that play button and run it with IIS or Internet Information Services Express. It will create a local web server which is available under the application URL. The other option to run this app is via the terminal or the package manager console. In that case, the application URL is different, namely localhost 5000. That's everything you need to know for now. The app settings JSON file is another settings file, of course. Here we can enter some settings we can access through the code. Later, when we add Entity Framework, we will enter the connection string for the database here, for instance. Now let's have a look at the bottom. We see the weather forecast class. This is just part of the API template. We don't really need it, but again, let's use this example in a minute. Next, let's have a look at the startup class. Here we find the configure services and the configure method. The configure services method configures the app's services, so a reusable component that provides app functionality. You can register services in this method so they can be consumed in the web service via dependency injection, for instance. The configure method creates the app's request processing pipeline, meaning the method is used to specify how the app responds to HTTP requests. With all these use extension methods, we're adding middleware components to the request pipeline. For instance, use routing uses a middleware pipeline where routing decisions are made. The startup class is specified when the app's host is built. You see that in the program class in the createHostBuilder method. Here the startup class is specified by calling the useStartup method. And now we're getting to the controllers folder. The first controller you see here is the generated weather forecast demo controller. We'll get to the details of controllers later. For now, it's only important to know that we can already call the get method here, what we're going to do next. So, what do we expect when we run the get method? In essence, it should return some random weather data for the next few days. Let's test that. As already mentioned, we can just press the play button in the toolbar to build and start the project and also run your default browser and already access this controller. A quick look at the launch settings JSON tells you that the launch URL for the IIS Express would be weather forecast. Just to be already clear on this, when you have a look at the weather forecast controller again, you see the class name weather forecast controller and the attribute route on top of the class. The string controller in brackets is a convention that tells the application that this controller here will be accessed by its name. And the name is everything that stands before the term controller. So it's just weather forecast. Long story short, let's run the app. As you can see, Chrome has been started and we already opened the proper URL and got the result of the get method. Random weather data for the next few days. To see the data a bit more organized, we can open the developer tools of Chrome and open the network tab. And because it's so much fun to see the weather, let's get the data with Postman. Just copy the URL from Chrome first. If you haven't already, make yourself a bit familiar with Postman. The essential part is in the middle. We can choose the HTTP request method, in this particular case it is get, and then enter the URL and hit send. The styling of this result should look similar to the developer tools of Chrome. Sweet. Now what about the port 5000? I told you that there's another way to run the application. The great thing about that way is that we can modify our code and the application restarts itself as soon as any change has been saved. So let's go back to Visual Studio, stop the app first, and then open the Package Manager console. You could also use the terminal, that's totally up to you. Here we first have to switch to the proper directory and then we can either enter .NET Run or .NET Watch Run and hit enter. With .NET Watch Run, the app will restart with any code change. That's why I like to use this command. The URL is a bit different now. In Postman, we replace the port, hit send again, and there is the weather forecast. Nice. Alright, everything seems to be in place. Let's initialize a Git repository now, and then we're ready to build our own controller. To initialize a repository, on the bottom right of Visual Studio, we click Add to Source Control and choose Git. As you can see, there is an option to already create a repository on GitHub, even a private one with your account. Additionally, you could add any existing remote repository, or you just create a local repository. Let's do exactly that. The great thing about that is that Visual Studio already creates a git ignore file, so you don't have to worry about all the generated binary files, for instance. Next to the Solution Explorer, we find the tab Git, where we can see all the files that have been changed. Now we are able to commit all our changes with every lecture, for instance, and get a clear history of our code. So far you learned how to create a web API project in .NET 5 from scratch and how to make your first API call with Postman. In the upcoming lectures, we will create a new controller and model for our contacts. With that, you will learn how to implement all CRUD operations with a web API. This means you will create, read, update, and delete data. But first, let's have a look at the Model View Controller, or short MVC pattern, which is the foundation of all this. Model View Controller, or short MVC, is a software design pattern that divides the related program logic into three interconnected elements. Let me explain what every single one of these three elements stands for and how they collaborate. We start with the model. You could also say the data. A contact is a model, for instance. It can have an ID, a first name, a last name, and so on. You as the developer know the code of your model, but the user won't see your code, of course. That's where the view comes in. The user probably wants to see a representation of the contact in HTML or plain text. In other words, the view is the user interface, or UI. To sum these two up, the model updates the view and the user sees the view. If the model changes, let's say our contact gets another name, the view will change too. That's why the model always updates the view. Now, what's up with the controller? The controller does the actual work. There you will find most of your code because it manipulates your data or model. In our case, it's the web API that will create, update, and delete your data. Since we won't have a view except the results of our calls in Postman, we are going to build our application in the following order. First the model and then the controller. And usually you would always jump back and forth between those two. With the help of the view though, the user can manipulate the data, hence properties of the contact with buttons, text fields, and so on. In a browser, that might be JavaScript code in essence, maybe with the help of frameworks like Angular, React, or Vue.js. The JavaScript code, in turn, uses the controller to do the manipulation and save these changes persistently in the database. The manipulated model will update the view, which is then again seen by the user, and the circle starts all over again. Well, that sums up the MVC pattern. Now we're going to build our first model. Alright, let's start with the model. In the Solution Explorer, we first create a new folder called Models. It's best practice to put your C# classes into the Models and Controllers folders. Inside the Models folder, we add a new item. This item is going to be a new C# class, of course. Let's call it Contact and then click Add. It's up to you what properties you want to give your contact. You can speed up adding the properties with the built-in snippet prop. Just type prop, hit tab, and there you go. I'd like to add an ID, which is an integer. Then a first name as a string. Also a last name as a string and a nickname. You know, Peter Parker is sometimes called Spider-Man. And then we've got a place as a string. And then for a change, a date time called date created. And we can set this already to a date time now by default. And finally, a Boolean value called isDeleted, which is false by default. Quite handy if you want to do a soft delete, so deleting an entry just by setting a flag and not really deleting it from the database. Alright, that's our model. Feel free to commit this to your repository. Next, we create the corresponding controller. Creating the controller is a bit different. We right-click the controller's folder, but instead of adding a new item, we choose controller. What a surprise, huh? You see now that we have a bunch of options here. We can ignore the MVC controllers, which are used for MVC applications. We want to add an API controller. We can choose between an empty one, a controller with read-write actions, and a controller with actions using Entity Framework. We will have a look at the last one later in this course. For now, it makes sense to choose the second option, the controller with read-write actions. That way, we already have some code we can build up on. And it's more realistic, because in a real-world project, you would never start from scratch completely. So please select this entry and click Add. After that, the correct item type has been selected. And yes, there would have been another way to add the controller. We name the new file Contact Controller and click Add again. As you can see, there has already been some code generated for us. In essence, we've got the CRUD operations prepared. But the actual logic is missing. Of course, we'll cover that. But first, let's talk about the contact controller in general, what it's derived from, and what these attributes above the class name actually are. Our controller derives from controller base. This is a base class for an MVC controller without view support. Since we're building an API here, we don't need view support. If, however, we would want to add support for views, we could derive from the controller class. But in our case, controller base is sufficient. The next interesting thing is the API controller attribute. This attribute indicates that a type, and also all derived types, is used to serve HTTP API responses. Additionally, this attribute enables several API-specific features like attribute routing and automatic HTTP 400 responses if something is wrong with the model. We'll get to the details when we actually make use of these features. Regarding attribute routing, that's already the next thing we see here. Next to the API controller attribute, we've got the route attribute. That's how we're able to find the specific controller when we want to make a call. You may remember this attribute from the weather forecast controller. The string we see here is API / and then controller in brackets. This means that this controller can be accessed by API and then its name, in our case, contact. So again, the part of the class name that comes before controller. The generated route here looks a bit different from the route of the weather forecast controller. In this case, the API string is missing. If you look through the web, some APIs use this string and some don't. In the end, it's up to you what you prefer. Alright, let's get into the contact controller and write some code. The first thing I'd like to add is a mock contact list that we can return to the client. If necessary, we can add any using directives by using the quick fix menu. So we create a private list of type contact and call it contacts, which is a new list, and let's already add some contacts here. First, a new contact with ID 1. First name is Peter, last name is Parker, nickname would be Spider-Man, and the place of this guy is New York City. The second one gets the ID 2. His first name is Tony, last name Stark, nickname is Iron Man, and I think he likes to drink Long Island iced tea, so that might be the correct place. Alright, with that in place, we can write the service call to receive this list. You see the get method here that returns two values. Instead of these values, we simply return the list of contacts. That's it. Let's test that. In the Package Manager console, make sure to be in the proper directory and then start the application with .NET Watch Run if it isn't already running. Again, that way the app restarts when it detects any code changes. As soon as the app is running, let's go to Postman and use the URL http localhost 5000/API/contact and choose get as HTTP request method. Hit send and there are our famous guys. Perfect. Now before we move on, let's recap all the HTTP request methods. You might have already seen these attributes like HTTP GET or HTTP POST on top of the methods. So let's talk about that next. The Hypertext Transfer Protocol, or in short HTTP, defines, as the MDN web docs put it, a set of request methods to indicate the desired action to be performed for a given resource. To this date, we can find 9 request methods in the documentation. The most common ones are get, post, put, and delete. These are the ones that are covered in this course, because you almost always can do everything that needs to be done with only these 4. Let's go over them shortly. The get method requests a representation of the specified resource. If you're using this request, you should only receive data from the web service and not send data to it. Of course, you might want to send certain characteristics to the service, like an ID or a string, and the backend then grabs the proper object from the database, but you won't send any objects to the service. You have already seen the get method in action. Sending objects to the service in turn would be done with the post request. The post method is used to submit an entity to the specified resource, often causing a change in state or side effects on the server. This means that you might want to add a complete new entry to the database, for instance. Post means, to put it simply, add or create a new object and do whatever you want to do with that object in the backend. Usually, this new object will be saved in a database. The put method replaces all current representations of the target resource with the request payload. So, this is in essence an update of the complete object. If you want to change a property of an object, let's say just the name for example, you would send the whole object to the service and it would overwrite the complete entry in the database. Of course, there can be variations of that process, but the standard way is exactly that. Send an object to the service that already exists and update every property of this object. And finally, the delete request. You know it already, the delete method deletes the specified resource. So you send an ID to the service via the URL. The service usually looks up the corresponding entry in the database and erases it. If you rather want to do a soft delete, meaning just set a flag so that this entry will not be shown on the client, it's actually an update where you would then use the put request method. But to make one thing clear, nothing works automatically. You have to write all the service methods by yourself and define which HTTP request method has to be used by the client. You could in fact write a service method that uses get, but then simply delete an object with the given ID. It's all up to you. However, one great thing about the Entity Framework Controller later in this course is that it does indeed generate usable code out of the box. Still, you almost always want to change a few lines. Now, how do the CRUD, create, read, update, delete operations match with the HTTP request methods in general? Maybe you know it already. To create an object, you would use post. Reading an object is done with a get call, updating with put, and deleting, well, with delete of course. So now you know. This HTTP get attribute tells the controller that the coming up method is a get method. But in this specific case, we could actually use this method without the attribute. You see, there are also naming conventions for the methods. And if a method name starts with get, the Web API assumes that get is the correct HTTP request method here. Now, if a controller has only one get method, this works fine. But if there is another one with the exact same parameters, this wouldn't work anymore, because the web service does not know which method should be called. That's where the routes come in. In our case, we've got the HTTP get attribute for the method to receive all contacts, and also the same attribute to get a single contact. As you can see, the method for a single contact has a parameter, the ID of the contact. Apart from that, you can also see the ID in curly brackets within the HTTP get attribute. This is actually the route. So you could have added a separate route attribute here, or just combine it with the HTTP request method. The curly brackets tell the controller that this is a parameter. So the string in these brackets and the actual name of the parameter have to match to make this work. Now, instead of returning the string value, of course, we want to return the contact with the given ID. Let's do that with the help of link. We return contacts, and then first or default, and then with the help of a lambda expression, we return the contact where the ID matches the given ID. And of course, we also have to change the return type to contact. Done. Thanks to our watcher, the app is restarting as soon as we save our changes. So we can switch to Postman and add an ID to the URL. ID 1 gives us Spider-Man. ID 2 leads to Iron Man. But what about ID 3, for instance? We get nothing back with a status 204, no content. Wouldn't it be nice to get a custom error message like contact not found? Let's do that next. You have already seen in Postman that we get a status 200 OK back if we use proper IDs for our contacts. This thing is a status code. Other famous status codes are 404 not found, 403 forbidden, or 500 internal server error. We don't like them, but we as developers still have to live with them, and even worse, we have to handle them. But we can change the status code. Isn't that great? Let's return a 404 not found if the user has entered a wrong ID, shall we? First, we have to change the return type to IActionResult. This return type is appropriate when multiple action result return types, meaning status codes for instance, are possible in a web service method. These action result types represent the various HTTP status codes. So with this type, we are able to send a 404 not found, a bad request, and so on to the client. Additionally, we can use the action result to wrap another result object, like the contact in our case. So let's change the return type again and make it an action result that wraps the contact type. Now we want to return a not found if an ID for a contact does not exist. First, let's try to get the proper contact before we return anything. We define a new contact, call it contact, and then use the first or default method again. We can already return the contact with OK contact, which results in a 200 OK status code. Now let's cover the case with a wrong ID. We check if the contact is null first. This is the case if the function first or default does not find a contact. If we would use the function first, an exception would be thrown instead. Just keep that in mind. So if the result is null, we return not found. Simple as that. We can test that again with Postman. ID 1 returns Spider-Man as before. But ID 3 returns the new 404 not found status code. But what about adding a custom error message? Easy. We simply create a new object with a property called message and add a string like contact has not been found to that. Testing that again in Postman delivers that object. If you think ahead, you could use that message for a front end to display the information to the user. At least that's better than a simple 404. Let's fix the other get method real quick. The new return type is action results of type IEnumerable and then contact. We can keep returning just the contacts because by default we get a 200 OK as status code. You see that again in Postman. Great, receiving contacts works. Let's create one now. When you have a look at the generated code of the post method, you see that it looks a bit different. First, the HTTP request method, of course. This time it is HTTP post, to make clear that we have to use post in order to access this method. Then we've got the from body attribute. This one specifies that a parameter should be bound using the request body. So far, we used the URL to specify the contact we want to see by providing its ID. When we want to create a new contact, there would be a lot of strings or integers we would have to enter in the URL. It would be even more complicated if we don't want to add a certain property, and some data types are just not easy to add to the URL, like a date, for instance. Anyways, it's a lot easier to use the request body. In this specific case, a primitive data type like a string could be used in the URL. That's why the from body attribute makes sense. But we want to send a contact object to this web service. That's already a non-primitive data type, and the web API assumes that this one will be sent via the request body anyway. So let's remove the attribute and change the parameter to contact new contact. Additionally, instead of returning nothing, I would like to return the complete list of contacts so that we see the updated list right away. For that, we can use the IActionResult type and wrap the list of contacts. The next step is easy. We simply add the new contact to the contacts list and then return that list. Let's test that in Postman. This time we choose post as request method and use the URL http localhost 5000 API contact. Now we need a body. To add one, we go to the body tab, then select raw, and in the drop-down on the right we select JSON. Now we are able to add a JSON object that will be sent to the service. We start with ID 3. For the first name, I'd like to use Bruce. Last name would be Wayne this time. Do you know the rest? Nickname would be Batman, and the place is Gotham City. Okay, let's try that by hitting send. Perfect. This works just fine. Keep in mind though that Batman will not be saved permanently yet. Later in the Entity Framework section, this will change. Now if you made it this far, you are definitely ready for the complete .NET 5 Web API and Entity Framework crash course. You seem to have what it takes to build a .NET 5 backend application with Web API and Entity Framework completely by yourself from start to finish. In the next sections of this course, you will complete the CRUD operations with your Web API and then add Entity Framework with code-first migrations and SQL Server. You will learn how to add a controller with actions using Entity Framework and how to implement all CRUD operations so that your data is stored in a SQL Server database persistently. As a thank you and reward for completing this part of this course, I want to give you a pretty sweet discount. Make sure to use the link in the video description below. I'm looking forward to seeing you again in the complete course.